Alright, really bad self-made video of the first successful multiplication circuit on this third generation cell matrix, which still needs to have another name. Three-sided cells requiring 1 megabyte each, as opposed to a much larger truth table for four-sided cells. We're using these three elements. We're sending one analog input into the left side here, another analog into the left side here, which is routed up through the K side. Cell 00 multiplies those two inputs from L and K, sends it out the right, and cell 01 takes the value from the left and sends it out the K output. The sim engine is set up right now to read inputs from any sides that we want, but the only output that's sent back for conversion to an analog signal is coming from 01K output. This is the Arduino board that's receiving analog inputs from two potentiometers, each running 0 to 5 volts. They go into two analog inputs. We're actually using inputs 3 and 4. The Arduino turns those into serial commands, sends them through the USB into the laptop, which is running the cell matrix engine. So we have a channel setup command, which lets us say channel 3 is connected to cell 00's left input, channel 4 is connected to cell 10's left input. So channel 0 is coming in here, channel 1 is coming in here, and we use the hand of God, as it's called, to specify what the truth tables will be. So, for example, truth table 00 has a truth table that basically takes the left input and the right input, multiplies them, shifts it right by 6, so divide by 64. Cell 10 takes the left input, sends it to side K, and cell 01 takes the left input and sends it to side K. So 00 goes from left to K, 10 goes from left to K, 00 takes left and K, multiplies it and sends it to the right, and 01 takes left and sends it to K. And I think that's what I said. Right, because 00 takes the product of left and K and sends it to the right. So we have the single output, which is coming on 6 digital lines because we transmit it as digital information. It goes through a simple 1-2 resistor ladder to give you a 6-bit D to A, which comes out on this orange line and goes into a voltmeter, grounded out. And now we can set one potentiometer all the way up to 5 volts, and this other potentiometer can be turned, and as we turn it, the voltage goes from 4.38 volts, that's as high as the D to A goes, all the way down to 0, and anywhere in between. And we can take the first potentiometer and divide that down. So now we're going from 0 up to 2.4, and the second potentiometer will run from 0 up to 2.4. Or we can cut that down and scale with the first up to approximately twice that value, or back down to 0. So we have a simple multiplication function, takes in two analog values between 0 and 5 and produces an analog value between 0 and 5.